So welcome to the third week of the Intro to Android course. This week we'll be talking about some of the more conceptual topics within Android development. That includes the activity, permissions, intents, and manifests. So some announcements before we start. Homework 3 will be an extension of Homework 2. But if you haven't completed Homework 2 yet, or if you feel unconfident about your answer, we will have a baseline good version of Homework 2 out by Wednesday after the slip day deadline, and you're definitely welcome to use that. And I just want to note that weekly homework might ramp up a little bit in difficulty, so please come early to our office hours. We have a ton on Tuesday, Wednesday, and Thursday. And if you have a question, please post within our Slack, our course Slack. It might feel a little daunting to post at first because your name is attached to your question. But rest assured, if you have a question, most likely someone else has the exact same question. So posting your question on there will help others as well. We also added an anonymous app to our Slack. So if you feel uncomfortable posting a question with your name attached to it, you can use this app to anonymously post a question. And just a warning, the app doesn't allow you to post pictures, but you are allowed to post code or text. And another initiative that we are starting is virtual coffee chats. And this is just an informal way for you to get to know the course staff if you want to. And these are meant to be used as office hours, so please don't come with your homework questions. But if you want advice or you have any questions or you just want to get to know us and talk about recruitment, Cornell, maybe life within San Francisco, or just talk about one of our interests, definitely reach out and schedule a meeting with us. So the first topic we'll talk about are activities. And Kevin and I have been throwing this word around for the past 2 weeks, but we haven't really officially defined it for you guys. And at a high level, you can think of an activity as a screen in an app. But just note that this may not always be true. It could be that the activity only takes up a segment of the full screen, or it could be that the screen that you see is actually a fragment, which is something we'll talk about in Lecture 5. Or it could be that the screen is just a view, like an XML, with no lifecycle methods attached to it. And so you might ask yourself, what does that all mean? That literally did not tell you anything about what activity is. And I agree. But here's more of a visual representation of what activity fragments views all mean. So the orange boxes show you what the activities are. So in this case, the activity is the full screen. And so we have the main activity versus the campus eatery activity. And then we have the fragment in the green box. And this fragment actually sits on top of the activity. And the reason why we have this is because we have a container that actually contains the fragment. And we actually switch out the fragments depending on what tab you click on. But for each fragment, we want to keep some of the elements the same. In this case, it's the action bar at the top and the bottom navigation bar at the bottom. And something we could have done is that we could have just repeated this code 3 times in 3 different files. But instead of repeating code, we just want to have it in one place and to avoid replicating code. And that in general is just good coding practice. So in this case, we have an activity that contains a container, which allows you to swap fragments in and out. On the second screen with the bar graph, this is actually an XML or a view. And this means that there are no lifecycle methods attached to this particular view. And it kind of is just created on the onCreate method. And this will make more sense as you start working with very complex apps. But just know for now that an activity and a fragment rely on lifecycle methods, which we'll talk about next, and views and XMLs are not attached to lifecycle methods. So in terms of the Android lifecycle, you don't need to know too much about the Android lifecycle unless you're dealing with data or very complex interactions within the app. But just at a high level, there's a few states you should be aware of that the app actually enters. So it's the starting state, running, when the app is actually running. Pause is when the app pauses. destroyed and stopped. And you can see that within all these 5 states, there are a lot of different methods that lead to these states, and you don't really need to know all of them at all. We'll kind of go through examples of ones that you should be aware of. So far within our homework and also just within like the demos we have shown, we've only been modifying code within onCreate, and for the most part, you'll probably only be touching onCreate. So onCreate is the most commonly used method and most commonly overwritten method in Android. This is called when the system first creates an activity and it's only invoked once per activity lifecycle. So once the activity already exists physically, the app actually doesn't recall this method. And for the most part, you'll be writing majority of your code within onCreate. This is where you specify your UI, where you set your listeners, and where maybe you call your networking. OnStart is called immediately after onCreate, and a lot of times code that's placed within here deals with state management. So later on when we learn about architecture, you can put your code or you can put your app in several different states, kind of like a finite state machine. And you can't really determine the state until your UI and your listeners and networking is already set. And this is, and OnStart might be a place where you actually deal with state management. Another method you should be aware of is onResume. This is called when the app goes from not running to running again. Oftentimes this happens when you are selecting the app from the background. And maybe on here you want to be pulling data from a database or you want to be recreating a UI. Another method you should be aware of is onPause. This is called when the user starts to leave the activity, but this doesn't necessarily mean that the activity is destroyed. And this could happen when the user backgrounds the app. OnStop is called when the activity is no longer visible or running to the user, and this occurs right after onPause. And this can happen when you leave activity A to go to activity B. And oftentimes this is a good place for you to commit data to the database, to make any changes you need to save any data in case that the user decides to destroy the app. And finally, we have onDestroy. So there are normally 2 different types of destruction. One type of destruction is very temporary. For example, this is when the user rotates the phone. As you saw with homework 2, sometimes when you rotate the phone, your entire UI gets destroyed, and onCreate is actually recalled again, and that's why your UI sometimes resets itself. The second type of destruction is when your app is physically dismissed and finished by the user. And in this case, you may want to save data, kill any processes to prevent memory leaks and such. So next we'll be talking about intents. Intents are ways for internal app components to communicate with each other, or for your app components to communicate with external apps. And there are 2 different types of intents, explicit and implicit intent. Explicit intents are the intents that you're more likely to use, and you've probably already seen it within our homework. We use it when we move from one activity to another. We also use it to pass information between internal app components. And Kevin will be showing you in the demo how to do this in the code base. But here's just a quick overview of how you might want to do this. So you will specify your intent, including the context and your target activity. You will use putExtra to send any information you want from the first activity to the second one. And it operates very similarly to a dictionary within Python. So you'll specify your key and the value being the message you want to send over. And then you'll just call start activity with intent. And then within your target activity, to retrieve the information, you would just get the intent, get the bundle, and then call your key, which will then spit back the value that you stored. So to show you how this works within the actual app, we're using Eatery as an example. Let's say, for example, I click on bare necessities. Instead of sending over an entire database of all the eateries, I would just send over intent saying, hey, I want to open up a new activity, and I will send over the eatery name. And what happens is that when I move over to my second activity, I would use this eatery name, go to my database, and grab all the information I need. And this allows us to create very dynamic activities without repeating a lot of code. And the second type intent is implicit intent. This type of intent is used when we want to share data with external apps. And Google has a super long list of all the different types of implicit intents you can send, but some examples include creating a shortcut on an app. For example, we want to create a widget, which is apparently very popular now that iOS 14 came out with them as well. You can share information like a message to another app. You can turn off your device screen or you can set an alarm. And I'll be going through some examples of what implicit intents look like in other apps. So in this example, I am opening up my favorite song on Spotify. And let's say I want to share the song with some of my friends. What I would do is I would click on the share button and it'll open up a list of different it'll open up a list of all the different apps I can send this song to. And what is crazy is that you actually don't specify, like Spotify doesn't specify this list of apps within their code base. What happens is that when you click the share button, an implicit intent is sent out in your device, and it kind of asks your device, hey, what apps are willing to receive my message? And all these different apps kind of raise their hand, and you're like, hey, I want to receive the message. And as you can see, when we click more, there are a ton of different apps that are willing to receive this message. In our case, we want to slide into someone's DMs. So we're going to open up Instagram and we're going to click send. And as you see in this example, like we are able to now send the song within the DMs. And what is crazy is that in this UI that you see here, we actually don't code this. If we were Spotify, we wouldn't code this. This is all coded within Instagram. And so sending a message to another app is actually very basic because all we have to set up is the intent part. And here's an example of an implicit intent within Eatery. In this example, we are calling this restaurant, and we just click the call message as you see here. The call, or I guess like clicking on that button automatically directs us to our device's phone app. And you can see that the phone number is already populated, and all the user has to do is click the call button. In this example, we can actually open up a different app within our own app. So for example, we click on a restaurant in this case, we click Visit Cafe Pacific, and we can open up Yelp, and it automatically opens up to the restaurant's Yelp page, as you see here. And including implicit intents inside your app is a really great way to make your app feel polished and also just feel very connected to other apps that your phone owns. Next, we'll be talking about the manifest file in Android. You've probably already seen the manifest file once in a while. It's called Android Manifest in the codebase, and it includes a lot of crucial information about the application name, the activities and fragments it includes, requested permissions, and like software requirements. For the most part, you probably don't need to be touching the Android Manifest file, especially since Android Studio will automatically populate this file every time you create a new activity or fragment. And if you are working on more complex features, generally you'll know when you need to modify it just through like Google or Stack Overflow. And one of the main things you should be aware of within the manifest file is the app launcher. So you might wonder how your phone knows what activity to open to when you open up an app. And I think oftentimes we take this for granted, but there's actually an intent filter specified in a manifest that tells your app or tells your device what activity to open up to. And oftentimes you don't need to change this because you'll just want to open up to main activity. But let's say, for example, you're refactoring main activity, and instead of like modifying the file, you decide to create a whole new file, then you might want to move the intent filter over to the second new activity that you have created. And so related to the manifest is permissions. I think oftentimes we like take permissions for granted, but this is a more serious and important topic now that we have been talking a lot about like I guess like user privacy within the tech space. And so a lot of common permissions that we might need a request for includes like location data, internet use, maybe storage or microphone data. And every time you want to use a specific permission within your app, you'll need to specify it within a manifest file. And below is sort of an example of what you might type in to like ask for find location data. And Kevin, again, will be showing a demo of how to request for permissions within the code base. And there are two different types of permissions. One is normal permission and one is dangerous permission. And normal permissions include things like internet use, maybe like the ability to kill all processes when you close the app. And normal permissions are basically permissions that don't really violate the user's privacy, so it's okay if they're just granted. And the system actually automatically grants normal permissions, so you don't need to do any checks for them really within your code. And you can kind of just assume that the permission is just granted. Dangerous permissions are permissions that actually do violate the user privacy. And this includes like location, storage, microphone, camera use. And you do need to ask for this explicitly within your code, and you need to account for situations where the user denies granting this permission. And yeah, you can't just like kick the user out of your app if they decide not to grant the permission. And there's 3 different types of situations that you have to account for. One is where the user denies all permissions all the time. One is where the user allows a permission only when the app is open and denies a permission when the app is closed. And finally, the user will allow the permission always. So you might ask yourself, why would I ever need to account for a situation where the user, wants to allow the permission always? And one example is like if you have a contact tracing app for COVID-19, and you want to send a notification to a user every time they come close in contact with someone who tested positive. Even if your app is closed, you still want to retrieve the user location so that you can send a notification if they do come in contact with someone. Or, for example, with like social media apps, not saying that this happens, but hypothetically, they could be like using your microphone even if the app is closed and using that data to send you very targeted ads. And these are sort of examples of screens or UIs that actually like notify the user when their permissions are denied. So in the first example, it comes from TikTok. I turned off my internet, and instead of just showing me a blank screen, TikTok actually shows me a screen that says like, oh, there's no internet, please turn on your internet so we can show you all this cool content. In the second example, I requested to record a video of myself, but I denied all my permissions because I do not trust TikTok. And they show me this dialog box that is actually very informative. It tells me like what permissions are not granted, and it kind of explains like why this might be happening. And after reading this dialog box, I might realize like, oh, it's okay if I grant permissions. I trust TikTok now. And I now allow TikTok to record my video, and now I can become like a TikTok star. So it's always important for you to think about different UIs that you can show in the event that permissions are not granted. Yeah, and that is the end of our lecture. We definitely talked about a lot of different types of topics, and it might seem very complex at first, but Kevin will be showing you how all these topics kind of fit into the code base in our demo.
Hey, welcome to the demo. All right, so this is lecture 3, and today we'll be covering the ins and outs of the ways to get data from one part of the app to another. This is not saving data necessarily, but just passing data along from one part of the app to another screen in the app. Right here, you can see that I've got a little demo app. I can increment and I can decrement this little counter. But watch as I flip it to a horizontal view. Huh. The number resets to 0. I can increment it again. And the same thing occurs. Why is that? Well, in Android, the number well, in Android, we recreate the app each and every time it changes view. When it changes from portrait to landscape, it refreshes everything on screen. Everything on screen is considered a new screen, essentially, because it has changed drastically from where it was before. So it just builds everything out again. Now, that's really good if you have two separate orientations like we just did in Homework 2. However, you kind of want some of those things still, right? Like if you filled out something and then switched it to portrait or landscape, you don't want everything to disappear, do you? If you want to save things from across that, there exists in Android something called the bundle. The bundle allows you to save things from one state of an app to another. All right, and here, actually, one moment while I make this a lot more readable for everyone. I noticed that the first time I did this. And we're back. Yeah, font size, right? So, now that we're here, let's take a quick look. Really simple code, right? Just grab the button, increment it. Grab the button, decrement it. Print it out to that text view. Dead easy code, right? However, in addition to onCreate being a thing and being something you can override, you can also override other things. Let's take a quick look at what it provides us. Override. What does it give us? It gives us a lot of options to choose from. In the specific case we're going for the function known as on save instance state. So what this will do is, when it swaps to another activity, it will save your current instance a little bit. Which currently it's not saving much of anything. However, you'll notice here there's something called a bundle. A bundle is where you store things that you want to pass from one activity to another. So in onSave instance state, if we do outstate dot put, and this is how you save something to a bundle, you put something in the bundle, right? In this case, we're going to put an int. We're going to give it the key of count, and we're going to put in our mcount. What this is going to do is put in our mcount into the state, into the bundle. Now, that alone isn't particularly useful, simply because you've never pulled it out again. You've now saved the count to a bundle, but you've never retrieved it from anything. What you're going to do after that is either override the on What you're going to do afterwards is either you override on restore instance state, which will restore your instance state like this. In here, you can do saved instance state dot get int, and then ask for count again. This should get you the count that you've just saved. And then we set that to mcount. And then we can, let's just copy this. Do that. And this should, if all goes well, save the number from one orientation to another. Let's give it a try. All right, that's embarrassing. All right. And we're back. So there was a persistent state here that wasn't supposed to be there. So if you override the onSave instance state outstate with only a bundle, and then use super on it, and then put it in the out state, you should be able to restore it just fine with an equivalent on restore instance state with a saved instance state of bundle. You get the right key, back again, and you should have absolutely no issue putting it into text. So let's give this a try. I increment it a few times. I rotate the phone, and it remains. I decrement it, I rotate the phone, and it remains exactly where it was. This is storing across rotations. So using on save instance state and on restore instance state across rotations. Now you'll notice something that like this on saved instance state thing, it's also here. But why? And why does it have a question mark? So this is pretty cool. On restore instance state is only called when the bundle exists. When there is a saved instance state, the bundle is restored. When there isn't, it's not called. So nothing here needs anything nullable. However, if you don't want to do it this way and you want to do it in the onCreate, you can actually, because the same onsaved instance state does end up in your onCreate, something that shows up ever since you started working on these apps. All you have to do is ask it from the saved instance state. Put a question mark there because that means it might be null, and if it is null, give me something that is, give me a null instead of throwing a null exception. Get count, like always, the same way you did it before with this one. And let's give it a backup plan. If it doesn't come out right, let's set it to 0. I'm going to cast this all to int, and then m count equals. No, that's the wrong way to cast. How do you cast the count again? Ah, there we go. So by this, it should also do the exact same thing as this piece of code, except it'll check if it's null, because this could be null. It might be when the app first started up. There, then we can just do this again. And run it, put it in the app. 6, rotate, 6, down to 2. Perfect, right? Now you have things saving across the same page. Now, what if you want to save it across, say, a second activity? Let's say that you, let's make a new activity, and empty. Empty, I like empty. Empty is good. Yeah, let's be lazy about it. Main activity 2. Let's let it automatically create it. And we have a second activity. In here, let's put something that does rely on the count, but, you know, might not be that important. Yeah. How do we know that we're in this activity if it's, you know, looking roughly the same? We will know by, let's say, I'm going to give it some placeholder text. Placeholder. Just so I can see how big it is. Or actually, hold on. Let's make it a number because it's going to be a number. Or not a number. Transferred data. I'm bland today. Transferred data. I spelled something wrong. Screw it. Transfer data equals 0. Data colon 0. And then in, let's go down to the size of the text, and let's make it massive. And let's say it's bold. You can also give it a fun color, like say text color. And I don't just want you to be gray, I want you to be bright blue. Lovely. And we're going to call this text view data, just to give it a distinguishing name. And then here, let's go text view data equals m count, and let's create a private m count variable. Private var m count equals 0. Text view data, dot text equals data colon m count dot to string. Nah, I will ignore your concerns, Android Studio. And from here, let's go in main activity and create a new way to get to the other app. So let's bind this to the bottom of that, connect it here, lock it to both sides, and then say that this thing is roughly pretty close to it. What is that? Yeah, 16. 16 sounds good. Bias. So now this is, 16% the way to the top and larger to the bottom. That's what that means. And let's give this a color. Background tint. You should be bright green. Button? No. Next. And you know what? That's looking pretty good. So what are we gonna do to get to the other activity? Button. Oh, is it just called button? I'm gonna give it a better name. Button underscore next is probably a better call. Equals, dot set on click listener. And here, we're going to call an intent. This is to tell the app that we intend to go to another screen. So I'm going to set up a new intent. It's going to be a value because its intents generally don't change much after you create them, unless you're really doing something weird. Intent, and initialize it with this. Yes, I want hold on. Yes, I want intents in my code. Alt enter. Is that? Yeah, import it, please. This. So it goes from this activity to the second activity, which we called main activity 2. Now, here's the thing. There are placeholders in Android Studio, which means that you generally call class, say, go to this class, go to the Java version of it. It's a placeholder, it's a remnant from the old days of Java coding. Just put this in there to whatever activity you're calling, it'll work fine. And then you apply some extra things to it. In this case, I'm going to put extra. I'm going to put in, the end count. So I'm going to call it count again. And I'm going to put end count. And put extra. Put extra is the generic version. It just checks whatever's in here and then just puts it in there. Yeah. So this is the equivalent to put it. You could do put it, I think. Nope, put extra. Put extra it is. When it comes to putting it into a bundle like this, use put extra. When you're calling it on the bundle, you can use put in. Can I use put extra here? No, put in. Okay. Yeah, so if you're sending it through an intent, use put extra. If you're putting it in a bundle like this, put in. Ah, right, because put extra puts it in a bundle in the intent. And this is directly calling on the bundle. There we go. Yeah. And then after that, just start the activity with the intent. Just checking. Can I do? No, probably not. Yeah, start the activity with the intent. And then this button should be able to send you into activity main 2. Let's give it a try. Increment, decrement, next. Oh, what? The data still says 0. Yep, because I didn't put anything to catch the data back again. So let's go back into onCreate, and this time let's do the exact same thing we did before. So I'm going to val intent equals get intent. This, actually, you know what? Intent works right here. Let's do intent dot extras dot let, and in here, let's get the bundle. So in here, we can do m count equals bundle dot get, and in here we do count, which should get from the bundle the count. Of course, we have to cast it as an int because it doesn't actually know the type of thing coming out of here. Kotlin's very type safe like that. And otherwise, let's just make sure that it does get something. Otherwise, it would actually, yeah, we could say, yeah, no, this works fine, and this should pass it through. Let's give it a try. Seven. And crash. What did I do wrong? I know I did something wrong. Why was it null? Because I misspelled it. I'm dumb. I'm a dumb. Yeah, there we go. So now it's able to grab count from the bundle and put it into end count to put here. So we've now been able to pass data from one screen to another. Isn't that great? All right, y'all might not think so, but this is really cool. So let's do one more thing. Intents, let's do a few more things. Intents not only can pass from one activity of your own app to another activity of your own app, they can also go elsewhere. So I'm going to create another button underneath here. Hey, hello. Tide. And let's say 24 pixels underneath that. Lovely. And I'm going to call this share. Because every app, some way or another, loves to have you share from one app to another, transfer data from one app to another app. It's one of the fundamental parts of computer science. You not just inside one application like its own OS. You can pass that data around. So one of the things we can do here is that I'm going to call this the button underscore share. And we're going to call button underscore share dot set on click listener. And in here, we're doing intents again. Let's make a new intent. And I'm going to fill this with nothing for now. I'm going to set the action to intent dot send action set. I'm going to set the intent put extra. I'm going to give it a message. That's one of the. You have to put a message inside a send action. And I'm going to say that the message says whatever's inside that text view data. Why is it screaming at me? Ah, right. Text. There we go. I'm going to do the same for the type, which the type of the message, what's contained in it is going to be plain text. So text plain. You can always find these resources for how to set one of these up online because this is kind of like putting in some code that you don't recognize. Yeah, so just look online for how to do your specific kind of sending. These are called implicit intents. They're not explicit. You're not sending to a very specific activity like you were before, where you send it to that exact Java class. You're telling the system, hey, I want to do something of this sort, and the system will take care of it. And then we start that activity with that, and we start an activity with that intent. And let's see what happens here. I'm going to say we have 7. We have data 7. That's going to be what we want to send. And hey, that's cool. It's telling us we can share with Gmail. Or copy it to the clipboard. Or send a message with it. Let's do messages. New message to, you know what, the old team lead. Ah, that's probably the source of it. Yep. You have to specify that it is intent, that this isn't just normal text. It's something specific that you want to pick up on the other end. So I'm going to say that this is extra text for the intent. And now the install should be happy. So I want to share this with Gmail. And it puts data 7 inside my Gmail. This is a general call to the system that I want to do this approximate thing. That I want to start up a message and say data 7. Somewhere in the system, I want to tell to the world, here's some text that I want to send out to people. Yeah. This is how you do an explicit intent. This is how file sharing works. This is how accessing Google Maps works. You can tell it to go, hey, I want to open up this location, or I want to open up a URL, and it'll just bring up a list of browsers. This is how sharing things for other apps works in Android, where you want it to send to a broad range of apps that can handle these things. Now, of course, yeah, let's cover a few more things before the end of this demo. Let's say we want to talk about this little bar up top. You don't like it? You want to put in your own? It's kind of unprofessional. It looks a little bit, jank. Yeah, no, I agree. How about we go into this? This is the Android manifest. You generally don't touch this much, but this is where it tells the application what everything is. So, it's telling the application that the main activity is the actual main activity, the one you launch from, which is what this category launcher is. It's saying that you start here first, and it's the launcher activity, and that this is just there, and it kind of just is. However, up here we also see a theme. App style. App theme. How about let's use something like yeah, the app theme. Let's click into the theme because this is going to be inside our theme values, right? So in our styles. Huh. Theme app compact light dark action bar. You can swap this out. There are many themes that are built into Android. One that you might like is a theme app compact. No action bar. Yeah. I like it light theme with without an action bar. How about that? The action bar is the top bar at the very top. If you want your app to look a bit more full screen, you can make that disappear. Now, this looks a bit more polished, doesn't it? Like, doesn't have that little demo tree at the top and that little bar up there. And a lot of apps love that use a bar up top anyway, love to customize and build their own bar beyond what Android provides by default. So this is something that a lot of developers like using. And finally, we're going to talk about using this manifest to request for things, to ask for permission. So we're going to go inside the XML and go, hey, we use permissions. We would like permission to do access the current location. Yeah, you need permissions for a lot of different things. So let's see. For general location, for finding out how the network is, for looking through the Wi-Fi, to answer phone calls. So many things require separate permissions to get because you don't want your app that you downloaded for your calculator to have permission to access your contacts, right? So these things are safeguards in place that each app that wants to do something has to ask for it explicitly. Let's go back into our main activity and put one more button in here. Let's call this button there. Let's bind it to a few things. Hello. And for this guy, yeah, I'm going to leave you all the way up there, and I'm going to say get location. Because what I'm going to try to do is get some location data. So button loc dot set on click listener. And in here, I'm going to try grabbing some location data. I have to first check if we have the permission. If not, we can't do anything. So context compat dot check self permission. I need to get this current context. Is this app currently permitted? And what I'm looking for is Android manifest permission group access find location, because that's really granular GPS data. If this is not package manager dot permission granted, if this is not permission granted, I can't do anything. I'm gonna chop this down a bit because this is looking a bit ridiculous now. And let's say if it is not granted, I would like to ask for the permission. So activity compat dot request permissions. And let's say this, you can ask for many permissions at once. In this case, we only need one. So I want that Android permission again. Each. Yeah, I want that Android permission. And I'm going to say 100. That's a request code. The request code could come back with, different things. In fact, actually, you can omit the request code, I believe. No, you can't. You need something. So that should ask for fine, detailed location from the user. If it is granted, however, I just want to put that into, yeah. Uh, let's just get the location. Location services. Ah, right. I haven't imported location services yet. Let's do that. So, hey, more things to tinker with. So inside Gradle scripts is where you put your libraries. In here specifically, the app module is where you put your most of your libraries. In this case, we're going to want Google's location services. Google Play location services is the default when it comes to, well, a lot of Android apps. Anything that goes on the Google Play Store probably uses their particular location services package because it's really nice and convenient. However, if you're developing for things that don't have Google Play services, such as you might root a phone and it might not have that, or you might be in China and you might not be able to access Google Play services, you might put in a separate location API. We're going to be using this one because we're currently in the US right now. And yeah, so now you can grab location services and say get fused location provider client for this. And that should give us a decent location. Now, location dot last location will get you a location data. All right. Cool. So I'm gonna do one quick thing to yeah. So in this case, let's get location, get the last location, and say so what we're going to do is we're going to get the last location and add an on-success listener after it gets the last location because this might take some time. After it succeeds, let's get the location, set the text of the view listener to it, which is location, dot latitude dot to string. And now it's happy. Let's and see what happens. Running. So let's do a quick overview of the emulator. There's actually a lot of cool extended controls. Like here, apparently my location is set to Palo Alto, Mountain View. And I'm going to allow this device to access my device's location. And boom, it gets me this location in Mountain View. Yeah, we can set the location elsewhere as well if we want to, say, click here and say set our location. Or let's go all the way across the United States to head to Ithaca, New York. A bit below Syracuse. There we go. Click on here. Let's set the location here. Oh, right. It gets last location and then doesn't really update much. Yeah. So to update it, we're going to need to do a few more things inside the location manager. But there's a bunch of amazing things you can do inside the emulator. You can change the exact tilt of the virtual sensors. You can say, move this virtually at this particular angle, tilt it this way, turn it this way. And then once it crosses a threshold, the system automatically thinks it's in a different position and will start moving and will start rotating it in that way. You can move it violently in the X, Y, and Z axes, and then the accelerometer will take note as well. You can also you can give it a phone call through virtual phone numbers. and it'll call your phone. You can take photos and add images to the photos in the virtual scenes. You can do so many things inside the emulator to pretend like this is a real phone and have really fine granular control over where everything is. So yeah, welcome to and I think that was that. So thank you all for watching. That was this week's demo. Yeah, enjoy the third homework. It's a continuation of homework 2, and I'll see you next week.